Good afternoon, Econ 140 students. Today I'm going to go over the second part of lab number 4. So the first part asks you to go over an example with the home price index, looking at running a regression using dummy variables and non-dummy variables. And the second part looks at using a new data set and doing some different things. And so I'm going to go ahead and go through that with you. So we're going to go through and calculate the descriptive statistics and talk about the mean of these values. We're going to run a regression using the variables available and talk a little bit about our findings. And then we're going to construct a new variable, an interaction term that combines the dummy variable of sex with the quantitative variable of experience level measured in years of employment, and talk about how interacting those two terms changes our interpretation. And we talked about this a little bit in the last Zoom, but I want to put something dedicated up, so if that's what you're looking for, you don't have to filter through a bunch of other stuff to get to the point you want. I'll also put up something separate where we look at doing it in Excel. So let's get started. So the first thing I want to do in my Stata workspace is import the H-price data set, or the, wage discrimination data set. I'm going to log what I'm doing as lab 4, part 2, and then my name, because that's how I keep track of stuff. Oops, wrong file. Just put that there. And then I want to go ahead, and I lost my import window, so let's open that back up and import the wage discrimination data set. And this is another data set that is available from the COOP textbook and the textbook website. I have also posted it onto Canvas, so you can find it there easily. There it is, wage discrimination. And I want to make sure, oh, that's what I did. So if you look at this data set, and I just already made a mistake, but I have it taken care of. So this data set has 2 lines of description, right? It has a descriptor line, salary, education, experience, and sex. And then it has the second line tells us the how these are measured. So salary in thousands of dollars, education in years, experience in years, and sex where male equals 1. So what you want to do, if you haven't already, is create a data set that doesn't have that level of detail. So I've done that with this new data set I called wage disc 1. And so now if I import my first row's variable names, I just have salary, education, experience, and sex. And I've lost that second row where it talks about the types of variables I'm talking about and the measurement of those variables. And so now I can import this, and I've got my variables. And the first thing I want to do is calculate the summary statistics. So in Stata, we just put in summary or summarize. And so I have 100 observations, and then I have my mean for salary, education, experience, and sex, and then min and max variable or values for those. And we talked about those a little bit in the Zoom, but for this purpose, for example 7.7, part 2 of the lab, I want to talk about what mean salary, mean education, and proportion of the sample is male. So I'll go ahead and put in my notes here. The average salary in this sample is $22,410.17. The average level of education is 2.8 years, and the average level of experience is 1.19 years. And then the next thing I wanted you guys to tell me is the proportion of the sample that is male. Since we know that 1 is male and 0 is female, that means that this mean of 0.31 tells us that 31% of the observations in this data set are 1, and the remaining 69% are 0. So I can say that 31% of this sample is male, while the remaining observations are female. Cool? So far, so good. If you want to create a, sorry, not a data editor, but so there's your data, and you can see the salary values, the education level, the experience level, and the sex. And we can see that what's dragging down this mean for experience and for education is a lot of values for 0. So this looks like a population without a lot of work experience and without a lot of education. We can also create a do file where we keep track of all of our commands, and that can help us if we have to start and stop this work, especially in these modern shelter and work from home times when a lot of us have a little bit more distraction than we're used to when we're working. That's a really good time to utilize that do file because it allows you to come back and go back to your work pretty easily relative to a log file that won't let you go back and re-edit it later on. All right, so pretty straightforward. That's part A. The next part is we want to run a multiple regression of Y on X1, X2, and D, report the findings, addressing the issue of wage discrimination in this occupation, and talk about the statistical significance of our variables. So I just want to do a simple multiple regression analysis of salary on education, experience, and sex. Oops. And the first thing I want to look at is my R squared, which is pretty high. So I could interpret the R squared as saying this model explains 86%, let's say it explains about 86% of the variation in salary. And if I want to keep saving all this in my do file, I will. So let's put that in there. Pull my do file back up. And then I want to talk about the validity of my variables and whether or not I can say much about sex discrimination in salary with my variables. So the first thing I notice is that if we're talking about using this data set to describe sex discrimination in salary, one big problem is that my variable of interest, sex, is insignificant. So we want to talk about that. Sex is not statistically significant. It's not a statistically significant explanatory variable with a p-value of 0.352. I cannot reject the null hypothesis at the 1%, 5%, or 10% significance level. So that's a problem. But the good news is all of our other explanatory variables are statistically significant at the 5% and 1% level, right? Our p-values are approaching 0. Our model explains a lot of variation. Our f-stat is high relative to its p-value, so we can reject the null hypothesis that r squared is 0. And then we have our coefficients here, which we can interpret. And so let's go ahead and interpret that. So we want to say that the two other explanatory variables are statistically significant at the 5% and 1% levels. An additional year of education will tend to increase salary by $504.60, holding sex and experience constant. And remember here, because this coefficient is 0.546, and we know our salary is in thousands of dollars, that means that it's $500,000, right? Or $504,000 or $504. So we can go ahead and scale that for our purposes. You don't have to say $500,000 because that doesn't make a lot of sense. So again, it's always useful to know what your units are with your explanatory variables and your dependent variables. So one additional year of education, a marginal increase in education, is going to tend to increase salary by 0.5 or $500, holding all else constant. And we are still going to hold sex constant because it's in the regression, even though it's not statistically significant. Just because it's not statistically significant doesn't mean it's not still in there. It's in the regression, so we have to account for it. Okay? The next thing we want to do is interpret experience. So an additional year of experience will tend to increase salary by $766.41, holding education and sex constant. The next question is, what can we say about sex discrimination? And we can't really say anything here, can we? We can talk about the marginal effect of education. We can talk about the marginal effect of experience, but we don't really see any clear effect of sex, mostly because it's an insignificant variable. It's a highly insignificant variable. What we could say, if it was significant, is that being male tends to decrease your salary by $266.89, because that's what this says. Having D equal to 1, and that's what our sex variable is, D equal to 1 means you're male. So being male is going to have a negative effect on salary. So if we were to interpret the estimated coefficient for sex, it shows a negative effect of being male on salary. The effect is $266.89, which is a little more than half the effect of a year of education. So the full interpretation of this coefficient would be, if it was statistically significant, we'd say that what this regression shows us is that being male tends to decrease salary by $266.89, holding education and experience constant. Okay, so that's one interpretation. The last part is we want to go ahead and create our interaction term. And remember, when we create these interaction terms, this z value, what we're doing is we're multiplying a dummy variable by a regular quantitative variable. So in this case, according to the assignment, what I want you guys to do is multiply the dummy variable of sex by x2 experience to create dx2. So let's go ahead and generate that. So remember, the command in Stata is gen for generate, and I want to name what I want my variable to be. So I'm going to call it s times experience, and it's going to be equal to, and then I just want to put in my sex variable, and then the asterisk is how I tell Stata I want to multiply, and then my experience variable, and then click enter, and I don't get an error, so it means I did it all correctly. If you do get an error, you might want to check for errors in spelling, in capitalization, something like that. That's usually the most common errors. And I can check to make sure that it all worked out appropriately by going ahead and summarizing my data one more time. And now I can see I have salary, education, experience, sex, and now sex times experience. It's got no missing observations. It's got a lower mean than experience, and that's because there's going to be all those 0 values for female values of experience. It's only going to count experience when it's male, because if it's female, D is going to be 0, and so multiplying it by any value for experience is going to give us a value of 0. So the maximum stays the same, the minimum stays the same, but the mean is pulled down by all those values for female experience that are now equal to 0. So now what I want to do is go ahead and run a regression of y on dx1, or on x1, x2, d, and z, and then check for the statistical significance of my new interaction term. So I'm going to do a regression of salary on education and experience, sex and experience. And now I see that sex is still statistically insignificant, but sex times experience is statistically significant at the 5% confidence level. It's not at the 99% confidence level, not at the 1% significance level, but it's borderline enough that we can count it in this and we can interpret it. So I'm going to go ahead and add that command into my do file. And then I want to go ahead and interpret my results. The specific results I want to give are, I want to know about the statistical significance of Z, and I want to talk about the change in the interpretation of these coefficients, these estimated coefficients, and how it changes our answer to the question of whether or not there is wage discrimination or salary discrimination based on sex. Okay, so first of all, the new interaction term of sex times experience is statistically significant at the 5% significance level.